Okay, so today we're talking about Unit 6.2, which is our definite integral. Last time we talked about approximations under the curve with our area. Now we're actually going to try and figure out true area under the curve using our definite integral. Okay, the first one we're going to look at is y equals the square root of 9 minus x squared. Some of us can look at that equation and kind of remember what that is, but that is a geometry kind of reminder. So here it is in our graphing calculator. Now we can see, what shape do you see? Well, it looks like a semicircle, right? You're absolutely correct. It is a semicircle. And this is what we're going to be doing for the first half today, was we're going to be talking about the area under the curve in terms of shapes. Okay, so right now I see a semicircle, so I can look at the area of a circle, which is, that's really thin. That's really thin. Pi r squared. Ooh. But we're not 100% with pi r squared because that's the area of my circle. I need the area of my semicircle, so I'm going to divide it by 2. Okay? The only other thing I need is my r, and I can come to my graph, and I can see this is center, so my radius must be 1, 2, 3. So this becomes the area equals pi r squared over 2, which equals pi times 3 squared over 2, which is 9 pi over 2, or 4.5 pi. Okay? That is the area of the definite integral. But I cannot forget the left-hand side. I can't forget my notation. So here it is. Oh, I forgot to tell you where we're coming from, but the definite integral from -3 to 3 of our function must be equal to the area under the curve, which is equal to 4.5 pi. Okay, here's another one. We're now doing the definite integral from -2 to +3. So what we have to do is determine our shapes under our curve. Okay, so I'm going to go ahead and highlight them because with this one, we can actually see our two bounding lines. So we have to be bounded by our function. The area has to be bounded by the function, and it has to be bounded by the x-axis. Okay, so this top part is pretty easy. Here is my function. Here is the x-axis. So this space must be what I'm looking for. Okay, but what about over here? Here's the part where most of my students have a little bit of disconnect. Okay, because here is my function and this is the x-axis. So we can't use this space because that's not near my function. We can't use this space because that's not near my x-axis. So it's got to be the space that's between the x-axis and my function. Okay? Now we have to determine a couple things. We have to figure out what those shapes are and what the formula for those areas are. And we have to look at, do we have any negatives, okay? So this shape right here, that's a big triangle. We could have seen them split up into two little triangles. That's acceptable. We could have also seen this as one little triangle and one square. Or you could see it as one big trapezoid and one big rectangle, which is actually the formula we ended up using. So the formula for a triangle, again, is base times height over 2, and the trapezoid was that base 1 plus base 2 times height all over 2. But where are my shapes? Well, my triangle is above the x-axis, so this is going to be positive. My trapezoid, however, is below the x-axis. Because it's below the x-axis, this one is going to be negative. Okay? So if I plug those values in, I get this. The definite integral from -2 to 3 of f of x dx is equal to the area of the triangle minus, normally we would add the areas, but if I'm adding a negative, I'm going to subtract it. So minus the area of that trapezoid, and I get my answer of 4. So the definite integral, the area under my curve, is going to be equal to 4. Okay, but what happens when we put +2? So where is that? That's outside of the original function. It's not attached to the function. So if it's outside, if we remember from pre-cal, these are our vertical shifts. And so what that does is this translate it 2 units up because it's positive. If it were negative, it would translate it 2 units down. So what does that look like? Boom, I moved 2 units up. And so what happened when I moved 2 units up? Well, sure, here is that original shape we already calculated, but I also created a new shape right here from my x-axis, which is this triangle right here. And of course we still have this line going up. right? Okay. So what we're going to do is we're going to go ahead and use our rule number 4, which is our sum and difference property, where we can just split it up. We saw that with derivatives. Well, we can do the same thing with integrals. We can just split it up. So what we did is we split up the first half, and because we have plus, we split up the second half. So the definite integral of -2 to 3 of f of x, we did that in question A, so we have that answer. But we need to figure out the definite integral of 2. Well, what shape did I create when I shifted up 2? I created a rectangle with a base of 5 and a height of 2. And so that's all I'm going to do. And remember, when we do these areas, we have something called net area, and what that means is that's the total area including my negatives. So why does this work? When I plug this in, here's that 4 from my previous answer. Here's my new rectangle. But what I get from a lot of kids is they want to know what happened to this space right here. What's going on? I have a trapezoid that's under the curve with a negative area, and when I move it up, that trapezoid is technically a part of my rectangle. Because of that, because this 4 was net area, both positive and negative area, because it's net area, even though it shifted, my rectangle now includes that value. So that's why it doesn't disappear. It's all accounted for. Okay, what happens when we put that +2 within my function, right? Because that's no longer outside my function, that's in it. Well, this is what we call those phase shifts. And we have to do what the opposite of what we think. We see +2, you might think it's shifting 2 to the right, but actually it's shifting 2 to the left. That's a pre-calc concept if you remember it, or trig concept. And so what does that look like? Okay, so I'm going to shift 2 units to the left. Well, this time I'm not creating like brand new shapes or anything. What's happening is I am creating brand new shapes, but I'm not like shifting it and putting a rectangle in or anything like that. So now we're looking at it from -2 to 1. So what we have to do is look at our new values according to the new graph that shifted. So this is -2 and this is +1 on my original coordinate plane. So now what are my shapes? Right here and right here. So this trapezoid we already know, but now we have to figure out this rectangle. Okay, so we're gonna, what we're gonna do is we're gonna use our property called additivity, and we're gonna do, we're gonna look at -2 to -1.5, and then we're gonna look at -1.5 to 1. So here's the area of that triangle, here's the area of the trapezoid, and all we do is plug in those values and we get our total of 1. Okay, example 3, I think you can do on your own. Okay, here we're at example 4, sorry. So example 4 is all about those 5 properties that I put at the front of your packet of packet 6.2. So for the first one we're going to be looking at is finding when our A and our B value are the same. So I'm going from 2 to 2. So you have to think, even though we don't know what this graph looks like, whatever my graph is at 2, if I'm not moving anywhere, how can I possibly create a shape? So if I cannot create a shape, what do you think my answer is? You are correct if you guessed 0. This is the 0 property rule. It's on your front packet. It's property rule number 2. Now we're going to be looking at, okay, well, what happens if I'm looking at, I keep going too far, sorry. What happens if I'm going from the definite integral from 5 to 1 of g of x? Well, what information were we given? We were given g of x from 1 to 5. So what happens when those values are switched? Well, all we do when we switch those values is change the sign on the outside. So this was originally a positive value, so now it becomes a negative value. This is rule number 1. Okay, so make sure you're double checking those. Okay, what happens when I'm still going from 1 to 2? Okay, cool, but what happens when I put this 3 in my function? So what were we given? We were given the definite integral from 1 to 2 of f of x, but what happens with that 3? Well, you guys have seen this with derivatives. We can pull the 3 outside and bring it back in when we solve our integral. So we know the definite integral from 1 to 2 is -4, so I just bring that 3 to it, and it becomes -12. This is the constant multiple rule, rule number 3 on that packet. You have seen this with derivatives, so this one you should recognize. Now what happens when I go from 2 to 5? Well, that's confusing because I have 1 to 5, I don't have 2 to 5. So how do I solve that? This is where we're going to apply where we pull apart it. It's not quite the sum and difference. This is called additivity, which is in your rules. And what we're doing is we're actually changing the intervals themselves, like we're splitting it apart. So you have to think, our original interval right here goes from 1 to 5. So we can see this value 2 in between. So now I have a new interval from 1 to 2, and then another interval from 2 to 5. That's the whole purpose of additivity, is to split those apart. So my interval from 1 to 5, we know that was a given value. That given value was 6. We did know that. Okay, the interval from 1 to 2, we were also given. We know that information. That is -4. Well, guess what? This is a simple math solve at this point. This now just reads 6 equals 4. Oh, I forgot to put, that's the one we're looking for. 4 plus some value. So we'll put the letter X. You should be able to solve that, -4. That becomes very easy. From there, that solve just equals 10, right? So now I know that the definite integral from 2 to 5, this missing value, must be 10. The additivity is rule number 5 on your packet. Okay, here's another rule. We're going from 1 to 5 of now this value, f of x minus g of x. You should recognize this rule. I got something plus or minus something, so that's my sum and difference rule. I can split it up. So now this becomes the integral from 1 to 5 of f of x minus the definite integral from 1 to 5 of g of x. We have both of those information, so we plug that in, 6 and 8, and we get -2. Okay. Here's another one, but this applies sum and difference and the constant multiple. So I can still split it apart. I just want to keep my constant multiple attached to what it was originally attached to, which was my f of x. So I plug those in. That becomes 4 times 6 minus 8, which is just 16. These were both rules 3 and 4. I think that's all we've got for you today. So please make sure you complete the rest of this packet in class, and we'll see you next time with Unit 7. Thank you so much.